Okay, for today's project, I basically took my infrared obstacle avoidance project, which I'll put links to that video down below in case you haven't watched it. You should 3D print the same parts and using the same H-bridge driver. But I replaced the infrared sensor with one of these ultrasonic sensors, which is normally meant to be used with an Arduino. In this case, we're not using any Arduino. And you can get these for less than $1 a piece if you do a little bit of shopping. And over on this side right here, this is a 555 timer oscillator. It comes smaller than this, but this is just one I had in my junk box. Take it stock, just the way they come. Again, less than $1. In this particular case, because it's the long one, counterclockwise is the higher frequency, so just keep turning it. You want the highest frequency you can get out of this thing. And then this little guy right here, that's a boost regulator, if the camera will focus. It's just a boost regulator to take the 3 volts, boost it up to 5, so I can get a clean 5 volts for the timer circuit and a clean 5 volts for the ultrasonic. The H-bridge is still running on 3 volts because it's driving the TT 148 gear motor at 3 volts. And it's not complicated. You just take your 5 volt boost from here. You got a ground and a 5 volt and run that into your timer. You take the output of the timer and you bring it over to the one they call trigger in on the ultrasonic unit, and then the out, receive out, echo out they call it. I have a 10K resistor coming over to the H-bridge. The H-bridge has been rewired, come on focus, been rewired to do reversing of the motor, just like in all my other obstacle avoidance videos. And bring the 10K over to that. Then I'm going to add a single capacitor between ground. In this case, I'm using a 22 UF and that input. And that's it. That's all you got to do. It's going to, well, let's turn it on. Let's see. Okay, so it's going forward. You see the wheel spinning. And then if you get something in front of it, then it's backed up and the wheel locks. So that makes it turn. I'll put it on the floor so that you can see it go. First, I'll just take a peek at the schematic just in case you're not clear on everything. These represent the 2 batteries, which give me my 3 volts. I'm running that through a switch to turn the positive on and off. I run that switched 3 volts into the boost regulator, which will then give me 5 volts out. There's only 3 connections on the boost regulator. You have power in, ground, and power out. Then I also run that 3 volts, as I mentioned in the earlier, over to the H-bridge, which has been wired to do auto reverse on a single control line. And it's pretty simple to do. The pins on the H-bridge are laid out just like you see here. You just bring one line over to here, connect these 2 inputs together, take that input, connect it to the V+. Again, that's +3 on this. And then you have your ground connection. The motor is right down here, connects onto that. Your device isn't running the right direction, just swap your motor leads around till it is. And so, coming out of the ultrasonic, well, maybe we work our way to it. Got the boost regulator, taking the 3 up to 5, running that into the 555 module. It only has 3 terminals. It has a positive input, has a ground, and then it has its output. So you're going to run your 5 into the 555, take the output, take it right up to the, let's see what they call it on here, trigger. I put a T there. I couldn't remember if it was for transmit or for trigger, but you're taking the output of the 555 to the trigger. You've got your +5 to there. You got your ground to there. Again, on the 555, turn it up to its highest operating frequency. If you want to be 15, 20 kilohertz, that's better. You certainly don't want to be at the slowest. Then the receive out one, got that 10K resistor and the 22 UF capacitor to ground, and then right in the middle of the 2, you bring that right over. And that's it. It's very simple. You don't need an Arduino. So now let's see if we can turn things around where you can see the floor. Maybe I'll have to go handheld on this. So hang on. It's going to be a little bit shaky. Okay. I think I got it. Hope I got it. And where's the switch? Let's turn it on. Let's see how it does. If it gets near me, I'll use my feet to steer it. Again, let's see how it does underneath there. Okay, I think I got by it. I'm using my foot here. Got that. Let's use my foot again. So it's just a very inexpensive, fun project. I wish there was a way to reduce the range so it didn't sense things quite so far away. It'd be better if it just had a couple of inches instead of a really long distance. Give you an idea of the range. I did try masking off some of the sensors on the front to see if I could just reduce that, but didn't really like that.